All right, the next thing I want to talk about is circular motion, centrifugal acceleration, centrifugal forces, and work. Excuse me. So if I take our typical object with centrifugal acceleration, a ball, and it's experiencing the force of tension, okay? We know from centrifugal acceleration that the force of tension is in this direction, okay? I shouldn't have done that like that. Okay, I know that the tension is in that direction. We know that the object is accelerating in this direction. Okay? Cool. We also know that the motion of the object is in this direction, at least at that given instant. So the velocity is in this direction. If I were to zoom in really, really microscopically towards this edge of this ball, like right here, if I'm zooming in on this little box right here, and I were to look at the displacement, we can say that there's a little bit of displacement in that direction. Okay, so there's a little bit of displacement in that direction, an infinitesimal amount. As a matter of fact, I should express this if I'm talking about calculus this way. Okay, so there's a little bit of a motion in that direction, a little bit of displacement in that direction. But if I look at this, I look at my tension being in this direction, and I have this infinitesimal amount of distance in this direction. Okay, here's my tension, here's my distance. Is there work being done? No. No work is being done. At least not by this tension. There may be other work in this system, but not by a centrifugal force. Centrifugal forces do no work on a system. The only thing a centrifugal force does is make an object go in a circle. So anything that moves in this circular path with a constant angular velocity, a constant rotational speed, is experiencing no work. Well, how do I do work when I do that? Well, try it. You actually have to whip it out. So if you're whipping it out in order to speed it up, so here's your hand, you have to whip it out in order to speed that object up. You're not trying to keep it moving in a constant motion. You're whipping it out. That tension shifts so that there's a component of the tension that's facing in that direction. That speeds it up. But the centrifugal force, the force that's required to keep the object to move in a circular path, can't do any work and will never do any work. And thankfully that's true, because if you think about it, what's different than a ball and a string from the planet Earth and the sun? I mean, this force of tension is replaced with the force of gravity. Okay? And it's applying a force on that object. Well, if that force, that center pointing force, was capable of doing work, and in some cases it is when you talk about comets and stuff, but not typically for planets, if it's capable of doing work, then the Earth would go faster and faster and faster and faster around the sun. It would be one heck of a ride after a while. Okay? So it doesn't happen that way. So this centrifugal force, the force that's center pointing, can't do any work. It never will do any work. Okay? So as long as an object continues to move in that circular path, no work is being done on it. Okay? Cool?